So we will be doing binomial theorem. So topic for today, binomial theorem. This comes under grade 11 topic and asked in the different competitive exams. In most of the competitive exams that are based on 11 and 12 syllabus, binomial theorem is one of the topics which is asked in almost all exams. So first of all, we will know what is binomial. What is a binomial? A binomial is simply an expression with two terms. Bi means two, okay? And nomial means terms. Nomial means term. So generally it is this binomial theorem is used for two expression, two terms. Nomial means terms. Okay. So suppose we have a plus b or x minus y. So these two have two terms, right? So we can say it is binomial. So if we expand manually, a plus b to the power 1 can just be written as a plus b itself. And a plus b square will be a square plus 2 times ab plus b square. And similarly, a plus b whole cube is a cube plus 3a square b plus 3ab square plus b cube. And this way. So what we see in all the terms, the power of a is a decreases and power of b increases. Here power of a is 2 in a plus b whole square and power of a is second term is 1 and power of b in second term is also 1. And now the power of b has increased to 2 and the power of a has decreased to 0 in this way. Okay. And how the coefficients follow the pattern? The pattern of the coefficient follows like 1, 1, 1, 2, 1, 1, 3, 3, 1, this way. Okay. So first of all, uh, Pascal was the mathematician who identified the relationship between the indices and the coefficients. So that is known as Pascal's triangle. How does it work? So here we are taking indices or power, and this is coefficients. Okay. So if the power or indices is 0, then it is 1. As we know that a plus b to the power 0, anything to the power 0 is 1. Okay. And if the power is 1, then coefficient will be 1, 1. A plus b has coefficient 1 and 1. And if the power is 2, then it will be 1 and add these two, 1 plus 1, 2 and 1. So power for a plus b whole square, the coefficient for it is a square plus 2ab plus b square, this way. And If the power or index is 3, then it will be 1 plus 2, 3, 2 plus 1, 3, and 1 this way. So a plus b whole cube is a cube plus 3a square b plus 3ab square plus b cube. So we see that power of a first term is getting decreased in each term and power of b is getting increased. And similarly, we have for power 4, we have 1, 4, 6, 4, 1 this way. If the power is 5, then 1, 1 plus 4, 5, 4 plus 6, 10, and 6 plus 4, 10, and 4 plus 1, 5, and at last 1 this way. And for power 6, 1, 6, and here I think we have mistaken 1 plus 4, 5, 4 plus 6, 1, 1 plus 4, 5, and 4 plus 6, 10. 10, 10, 5. Okay, so 1, 1 plus 5, 6, 5 plus 10, 15, 10 plus 10, 20, 10 plus 5, 15, and 6, and then 1 this way. Now, general binomial theorem formula. What is binomial theorem formula? So, a plus b to the power n can be written as nc0, okay? A to the power n and b to the power 0 plus nc1, a to the power n minus 1, b to the power 1, nc2, a to the power n minus 2, b square, and so on. Goes to ncn, a to the power 0, b to the power n. So we can observe that the power of A is getting decreased from n to 0 and power of B is getting increased from 0 to n this way. Okay. And here we know that NC0 and NCn equals to 1. NC1 and NCn minus 1 equals to n. And NCR can be written as factorial n, factorial r, and factorial n minus r. So if we have a minus b to the power n, then in that case, a to the power nc0, a to the power n, nc0, nc0. nc0, a to the power n, b to the power 0, and now next term will start with the negative sign. So nc1, a to the power n minus 1, b to the power 1, and plus nc2, a to the power n minus 2, b square, and so on to ncn, a to the power 0, b to the power. And depending upon the value of n, whether it will be negative or positive sign. That depends upon. So here it will be minus 1 to the power what? N. It depends upon n. If n is odd, then it might be negative term at the end. And if n is even, then it will be positive term. Okay, so alternatively, we are taking positive and negative term. Here it will be negative and C 3 a to the power n minus 3 b cube, and here it will be positive. So alternatively, we are taking positive, negative this way. Now how to find general term. Suppose in the expansion of a plus b to the power n, we have to find Rh term, okay, or r plus 1h term. So to find particular term, suppose we have to find tr plus 1, this will be ncr a to the power n minus r and b to the power r. If there is a negative sign between a and b, between two terms, then we can take minus 1 to the power r as well. So this is called general. Now let us take an example. Suppose we have to expand x plus 2 to the power 10. Okay. And we need to find, let's say, sixth term, fifth term. Find fifth term or sixth term, whatever. So if we want to find fifth term, then we can write this way t4 plus 1. And then we will take n is 10, 10c4. In place of r, we will be taking 4, not 5. 10c4 and x to the power 10 minus 4 and 2 to the power r is 4, 2 to the power 4. So fifth term will be 10c4 x to the power 6 and 2 to the power 4. Now we will solve it. So 10c4 will be 10 into 9 into 8 into 7. And here it is 1, 2, 3, 4. Okay. So how to expand this? Factorial 10 divided by factorial 4 and factorial 10 minus 4, that is 6. This way. So 4, 2 times 8, 3 times 9, x to the power 6 and 2 to the power 4 is 16. So it becomes 7 3 times 21 into 10, 210 into 16, x to the power 6. So this will be x to the power 6. This will be the fifth term. So general term is used when we have to find a specific term, okay, in the expansion. Suppose we have x plus 1 to the power 12, and we need to, let us take an example. Let us take an example. Find 10th term in the expansion of x plus 1 to the power 20. 15, let's say 15. X plus 1 to the power 15. So we will find the general term, right? So general term is tr plus 1. We have to find 10th term. So we will take 9 plus 1. 10th term can be written as t9 plus 1. And then we will take ncr. N is 15. Cr is 9. And x to the power 15 minus 9 is 6. And 1 to the power 9. So whatever the power of 1 is, the value is always 1. So we just have to solve this 15c9 x to the power 6. So this will be the 10th term. And also, if we have, let us take an other example. Find the find the coefficient of x to the power 6 in the expansion of 2x minus 3 to the power 10. Okay, this is the question. So we have to find the coefficient of x to the power 6. So again, what we'll be doing, we'll find general term. So general term will be t r plus 1 and c r, and see in between 2x and 3 we have negative sign. So we have to take minus 1 to the power r also. Okay. So 2 and c r, n is 10. So let us write this way: 10 cr 2x to the power 10 minus r, and either take minus 3 to the power r, or you can take 3 to the power r and then minus 1 to the power as you wish. So we can take minus 3 to the power r. Now it depends upon r whether it has negative value or positive value. So 10 cr 10 cr and 2 to the power 10 minus r can be, we can write separately, and also minus 3 to the power r and x to the power 10 minus r. Now we have to find the coefficient of x to the power 6, right? We have to find the coefficient of x to the power 6. So for x to the power 6, we must have 10 minus r must be equal to 6. 10 minus r must be equal to 6. Okay. So if 10 minus r is 6, then value of r will be 10 minus 6, which is 4. So r is 4. R is 4. Now, just we need to put the value of r, and this will be the coefficient. This whole thing will be the coefficient, okay, of x to the power 6. So we have 10c4 coefficient equals to 10c4, 2 to the power 10 minus 4, that is 6, and minus 3 to the power 4. So this becomes 10, 9, 8, 7, 1, 2, 3, 4. And 2 to the power 6 is 64. Minus 3 to the power 4 is obviously 81. 4 to the 8, 3 to the 9. So we just need to multiply it. So 210, 64 into 81. This will be the coefficient of x to the power 6. Okay, we just need to multiply. So 210 into 64, 210 into 64 into 81. And that comes to 10,886,4. This will be the answer. And apart from this, we also use general term to find the middle term as well. So how to find middle term in the binomial expansion. So in the binomial expansion, we will be finding middle term. Suppose we have to find the middle term in the expansion of a plus b to the power n. Now it depends upon the middle term will depend upon the value of n. So first case n is even. So we can easily observe that in the expansion of a plus b to the power n in binomial expansion, we will have n plus 1 terms. Why n plus 1 terms? Because it starts with nc0, okay, and ends with n. So from 1 to n, there are n terms, and including nc0, the term including nc0 will be n plus 1 terms. So if n is even, then n plus 1 is odd. So which term will be the middle term? Therefore, n plus 1 is odd. So n plus 1 over 2, 2th. Okay. This will be the n plus 1 is even. Oh, okay. It's even. So it's even number. Then just we have to divide by 2. N plus 1 by 2 will uh, be a specific term, right? So, and let's take an example. If we take n plus 1 will be odd, na? N plus 1 will be odd. So, if n plus 1 is odd, then we have to add 1 also. Okay. So, this much, and then we have n plus, I think we are doing something wrong. Yes. Let us take an example. If n is, suppose n is even, that is 10 terms. So how many terms will be there? 11 terms. 11 terms will be there. If 11 terms are there, then we just add 1 to it and divide by 2. So this will be, yes. So this will be the middle term. This will be the middle term. So we have n plus 2 over 2, 2x term. And case 2, n is odd, then n plus 1 is even. So in case of even number of terms, we have actually 2 terms in the middle. So first term will be n plus 1 by 2x term, and then n plus 1 by 2 plus 1x term. we can write this n plus 1 by 2x term and n plus 3 over 2x term. These two terms will be the middle term. So how to find the middle term? Let us take an example. Suppose we have find the middle term in the expansion of a plus x to the power. So what will be the middle term? So middle term will be obviously, so a plus x to the power, let's take n as 10. Okay. So n is here, n equals to 10 is even. Okay. So number of terms will be 11. The number of terms in the expansion will be 11. So sixth term, n plus 1 equals to 11. So 11 plus 1 over 2x term will be the middle term. So 12 over 2, that is sixth term. And then we will use the formula for that we have used for general finding general term, that is T6. T6 can be written as T5 plus 1, and expansion is we have NCR, N is 10, so 10C5 and a to the power 10 minus 5, x to the power 5. This will be the sixth term or the middle term. In case of and when n is odd, let us take another example. Find the middle term in the expansion of x plus 2 to the power 11. So n is odd over here. N equals to 11 odd. So n plus 1 equals to 12. Therefore, middle terms will be, there will be two middle terms. 12 over 2, that is 6th and 7th. Both the terms will be the middle term. So we will find T6, that will be n is 11. So 11C6, x to the power 11 minus 6, 5, and 2 to the power 6. And seventh term will be, this is sixth term now. Okay, sixth term will be 11C5 because 6 can be written as 5 plus 1 this way. So, and here it will be 6. Just a minute. So T6, right? T6 can be written as T5 plus 1. So 11C5 and x to the power 11 minus 5, 6, and 2 to the power 5. And seventh term will be T7 will be T6 plus 1, that is 11C6, x to the power 5, 2 to the power 6. The two terms will be the real term. So these were the basic concepts of binomial theorem. So typical exam questions are asked on the basis of expansion, finding general term. Questions asked finding for the expansion, yes. Finding general term, to find general term, to find middle term, to find coefficient of a specific term, approximation. In approximation also we use binomial theorem, and to show factor of a given. Sometimes suppose we have to prove the a minus b is a factor of a to the power n minus b to the power n. In such type of question, to show factor of sum or difference of two terms. For example, suppose we have to show a minus b is a factor of a to the power n minus b to the power n. In such question also we use binomial expansion. That is all for today. In the next class, we'll be doing problems based on binomial expansions. Thank you.